November 16th, 1896. Buffalo, New York. Street lamps ignite across the city, not from gas, not from local generators, but from electricity transmitted 26 miles through copper wire from Niagara Falls. The newspapers celebrated it as a miracle of the modern age. What they didn't focus on was what made it possible. Not the transmission lines, not the generators, the chambers. Massive underground chambers carved into bedrock beneath one of the world's most powerful waterfalls, spaces so vast that standing inside them felt like entering a cathedral, built for purposes no one fully explained. The official story tells you about Nikola Tesla's alternating current, about the triumph of Westinghouse over Edison, about progress and innovation lighting up America. All true. But there's another story buried in the engineering reports from 1896, a story about what was actually built beneath Niagara Falls in the years leading up to that historic moment. Because the scale of the underground construction didn't match the stated purpose. The architecture was too grand, the chambers too precisely engineered, the tunnel networks too extensive for simple power generation. From 1892 to 1894, crews dug a horseshoe-shaped tunnel system that stretched over 2,000 meters underground, 5 meters wide, 6 meters high, located 49 meters below the surface. They used 20 million bricks to line it, 800,000 meters of lumber for interior support. 28 workers died during construction. For context, that's a death rate comparable to building the Hoover Dam, except this was 3 decades earlier with far more primitive equipment and safety standards. Why so deep? The official answer was to create a tail race tunnel, a passage to carry used water from the generators back to the lower Niagara River. Practical, necessary, except the dimensions tell a different story. 18 feet by 21 feet, requiring over 3 years to build, lined with 16 million bricks in a 4-course pattern. That's not a drainage tunnel. That's infrastructure built to last centuries, built with precision that suggests purposes beyond moving water. The Edward Dean Adams power plant sat at the centre of this underground complex. McKim, Mead and White designed it, the same architectural firm behind Penn Station and the Brooklyn Museum. They didn't just design a power plant. They created what contemporary observers called cathedrals of power. Massive open spaces with vaulted ceilings, circular windows measuring over 14 feet high, intricate brickwork forming patterns that served no obvious functional purpose. The building stretched nearly 140 meters when completed, housing 21 generating units that together would produce 50,000 horsepower. But here's what makes no sense. The chambers housing those generators were excavated to depths far beyond what the equipment required. The vertical shafts dropping 135 feet into bedrock. The wheel pits carved with geometric precision. The transformer chambers built with load-bearing capacities exceeding anything the documented machinery needed. It's as if the engineers were building for equipment that didn't exist yet, or accommodating specifications that weren't in any public record. Competing companies built parallel systems. Jacob Schoelkoff's hydraulic power and manufacturing company had been generating electricity at Niagara since 1882, long before the Adams plant. By 1896, Schoelkoff had expanded his operations dramatically, enlarging his canal from 30 feet wide to 100 feet wide, from 6 feet deep to 14 feet deep. He constructed powerhouses at the base of the river slope with steel penstocks carrying water through a 210-foot drop to the generators below. 2 separate companies, 2 independent tunnel networks, 2 elaborate underground complexes built within years of each other, both featuring chambers far larger than their stated purposes required. And both systems aligned with a plan proposed in 1886 by Thomas Evershed, a New York State engineer whose original vision was even more ambitious. Evershed wanted to bore a 4-kilometer tunnel under Niagara Falls itself, feeding 38 vertical shafts that would power hundreds of mills above ground. His plan called for generating 200,000 horsepower, 4 times what the Adams plant eventually produced. The Evershed plan was officially rejected as too expensive, too ambitious, too impractical. Yet the tunnel systems built in the 1890s followed his basic design principles. underground passages, vertical shafts, chamber networks extending far beyond the immediate powerhouse locations, almost as if parts of his vision were constructed anyway, just never acknowledged in the official record. The 1896 documentation shows something else unusual. The transformer house built adjacent to the main powerhouse was constructed from locally quarried limestone, the same material used in structures meant to endure for generations. The chamber walls were finished with a level of craftsmanship that exceeded industrial necessity. The lighting systems, the ventilation networks, the access corridors, all built to standards suggesting these spaces were intended for more than housing electrical equipment. Workers who descended into these chambers described them as eerily quiet, despite the massive machinery, as if the acoustic properties had been carefully designed. The temperature remained constant regardless of season, suggesting thermal engineering far more sophisticated than simple insulation. And the geometric precision of the excavations, the perfectly level floors, the precisely angled walls, all achieved with hand tools and primitive surveying equipment in the early 1890s. Something about these chambers felt deliberate beyond their stated purpose. The question is what that purpose actually was, and why the engineering reports from 1896 documented the technical specifications in meticulous detail while remaining strangely vague about the reasoning behind certain design choices. Choices that only make sense if you assume the builders knew something about energy, about architecture, about underground construction that wasn't supposed to be common knowledge in the 1890s. By November 1896, when Tesla's alternating current system successfully transmitted power 26 miles to Buffalo, the underground chambers beneath Niagara Falls had already been operational for over a year. The first large generator had been tested successfully on April 15, 1895. The switch that powered Buffalo's lights and streetcars simply proved what the engineers already knew. The system worked. But the question nobody asked publicly was why those underground chambers were built the way they were, because the scale didn't match the technology. Consider the numbers. The horseshoe-shaped tunnel built between 1892 and 1894 measured over 2,000 metres long, 5 metres wide, 6 metres high. It's at 49 metres underground. 20 million bricks lined its interior. 800,000 metres of lumber provided structural support during construction. 28 workers died building it. The tail race tunnel stretched 7,000 feet, 18 feet by 21 feet in cross-section, requiring over 3 years to complete and another 16 million bricks. These weren't modest utility tunnels. These were subterranean highways. The generators they housed produced 5,000 horsepower each, 10 generators total, 50,000 horsepower combined. Impressive for 1895, certainly. Revolutionary even. But here's what doesn't add up. The chambers were designed to hold 21 generating units. Only 10 were initially installed. The spaces remained vast, echoing, mostly empty. Load-bearing walls built to support weights that never materialized. Ventilation systems circulating air through volumes far exceeding operational necessity. Access corridors leading to sealed sections that serve no documented purpose. Why build for 21 units when you're only installing 10? The standard explanation claims they were planning for future expansion. Reasonable enough, except the architectural drawings show something unusual. The empty spaces weren't simply reserved for additional generators. They were finished spaces, completed chambers with the same limestone walls, the same acoustic treatment, the same thermal engineering as the operational sections. You don't finish spaces you're planning to excavate later. You leave them rough, unfinished, ready for modification. Unless those spaces already served a purpose that wasn't being documented in the official electrical generation reports. The transformer house next to the main powerhouse offers another clue. McKim, Mead and White, one of America's most prestigious architectural firms, designed it. They're known for grand civic buildings, museums, monuments. Why hire architects of that caliber for an industrial facility? The official answer emphasizes the project's importance, the need to showcase American engineering prowess. Fair enough. But the design choices, tell a different story. Circular-topped windows measuring over 4 meters wide and 4.5 meters high. Intricate brickwork in patterns that serve no structural function. Interior spaces observers called cathedrals of power, as if comparing them to religious architecture rather than industrial facilities. The limestone used in construction was locally quarried, yes, but cut and fitted with precision that exceeded any practical requirement for housing electrical equipment. This wasn't just about showcasing technology. This was about creating spaces that felt significant beyond their stated function. And then there's the acoustic mystery. Multiple workers who descended into the operational chambers during the 1890s described the same phenomenon. Despite massive generators spinning at tremendous speeds, despite water rushing through enormous pipes, despite all the mechanical violence of industrial-scale power generation, the chambers remained eerily quiet. Not silent, but muted, as if the sound was being absorbed by the architecture itself. Modern acoustic engineers examining historical photographs have noted the chamber designs incorporate principles of sound dampening that weren't formally understood until decades later. The angles of the walls, the materials used, the proportions of the spaces, all combine to create unusual acoustic properties. Why would you engineer silence into a power generation facility? There's no operational benefit. The workers needed to hear machinery to monitor its function, to detect problems, to ensure safety. Deliberate sound dampening makes their jobs harder, not easier. Unless the acoustic design wasn't about the machinery at all. The temperature consistency presents another puzzle. The chambers maintained constant temperatures year-round, despite seasonal extremes above ground, despite the thermal output of the generators, despite the massive volumes of water flowing through the system. Simple insulation doesn't explain it. The chambers were carved from bedrock 49 meters underground, yes. But that depth alone doesn't account for the degree of thermal stability documented in worker reports. The ventilation systems were too sophisticated, too precisely engineered, as if someone understood principles of underground climate control that weren't supposed to exist in the 1890s. Here's what makes all of this genuinely strange. Both major power companies, Adams and Scholkopf, built parallel systems exhibiting the same characteristics: oversized chambers, acoustic dampening, thermal engineering beyond stated requirements, finished spaces exceeding operational needs. Two independent companies, theoretically competing, somehow arriving at identical design philosophies that couldn't be justified by the technology they were supposedly housing, unless they were both following specifications that came from somewhere else. Unless the Evershed plan from 1886, officially rejected as too ambitious, actually provided the blueprint they were secretly implementing. Unless those underground chambers beneath Niagara Falls were built to accommodate something far more significant than alternating current generators and transformers. Something that required geometric precision, acoustic control, thermal stability, and massive empty spaces that could be sealed off from official documentation whenever necessary. The 1896 records capture a moment when the technology became visible, when Buffalo's lights proved the system worked. But what they don't explain is why the infrastructure beneath that technology was built like something ancient, something monumental, something that had nothing to do with electricity at all. The construction records tell you everything you need to know if you're willing to read them properly. 28 workers died building these tunnels. 28 men lost in accidents across 3 years of excavation, 49 meters underground. That death toll isn't unusual for projects of this scale in the 1890s, but what's documented about how they died reveals something far more disturbing than standard industrial accidents. Most casualties occurred in the deepest sections. Not during the initial excavation phases near the surface, not while lining the upper portions with brick, but specifically when crews reached maximum depth and began carving out the largest chambers. Official reports cite cave-ins, flooding, equipment failures. Standard explanations for dangerous underground work. But personal letters from surviving workers archived in local historical societies describe something different. They mention sections where the rock changed texture, areas where tools broke against surfaces that shouldn't exist at those depths, chambers they were instructed to seal immediately after discovery, then never speak of again. One foreman's diary from 1893 includes a single cryptic entry: "Found older work today. Crew ordered out. Section filled by morning. No further context. No explanation of what older work meant or why it required immediate burial." The entry sits between routine notes about brick deliveries and shift schedules, as if discovering pre-existing construction 49 metres beneath Niagara Falls was just another scheduling inconvenience. The tunnel dimensions themselves create problems for the official narrative. 2,042 metres long, 5 metres wide, 6 metres high. That's massive. Far larger than necessary for conveying water to 10 generators. The horseshoe shape, the precise measurements, the structural reinforcement using 20 million bricks and 800,000 metres of lumber, all of it suggests preparation for something beyond simple hydraulic flow. You don't build cathedral-scale infrastructure to house machinery that could function in spaces half that size. Then there's the tail race tunnel. 7,000 feet long, 18 by 21 feet in cross-section, requiring over 3 years and 16 million bricks to complete. It discharged water near where the Rainbow Bridge stands today, miles from the powerhouses. Why route the water so far? Simple gravity discharge would work. Shorter tunnels would cost less, take less time, risk fewer lives, unless the goal wasn't efficiency, unless someone needed specific underground routes connecting specific locations for reasons that had nothing to do with power generation. Both companies followed Evershed's rejected plan. That's the detail everyone overlooks. In 1886, Thomas Evershed proposed a system too ambitious to build. A 4-kilometre tunnel feeding 38 vertical shafts, serving hundreds of mills in a completely integrated underground network. Officially impossible. Officially abandoned. Yet by 1896, 2 supposedly competing companies had constructed parallel systems implementing the exact same design philosophy. Different ownership, identical execution. The Adams plant with its 21 generating units in deep excavations. Schulkopf expanding his canal to 100 feet wide and 14 feet deep, building powerhouses with 210-foot drops to the generators, both creating vast underground spaces, both following a blueprint that was never supposed to exist. Consider what that means. You can't accidentally build the same impossible thing twice. You can't independently arrive at identical solutions to problems you're not supposed to be solving, unless the Evershed plan wasn't rejected, unless it was classified, unless both companies received the same hidden specifications and built them under the public cover of competing electrical ventures. The acoustic properties, the thermal stability, the geometric precision, none of it serves electrical generation. But all of it serves something. Spaces designed to be sealed, chambers built to specific frequencies, temperatures maintained regardless of surface conditions. Infrastructure that looks like power generation equipment was installed inside something far older, far more deliberate, something that existed before anyone decided to harness the falls for electricity. What if the generators were never the point? What if 1896 wasn't about proving Tesla's alternating current could reach Buffalo? What if the entire hydroelectric revolution at Niagara Falls was cover for accessing, studying, and potentially reactivating whatever those workers found in the deepest sections? The sections they were ordered to seal, the sections that cost 28 lives, the sections whose construction records disappeared from official archives within decades of their completion. You can still visit some of these tunnels today. Guided tours, educational displays, polished historical narratives about industrial progress and human ingenuity. They'll show you the accessible portions, the sanitized spaces, the areas that confirm everything you've been taught, but the sealed sections remain sealed. The deepest chambers stay closed. And the records from 1896, the ones documenting what was really discovered beneath Niagara Falls, those records exist only in fragments, scattered across collections that were never meant to be examined together. The workers knew something. The engineers suspected something. The competing companies coordinated something. And in 1896, when they finally powered Buffalo's lights and declared victory for modern science, they simultaneously buried the evidence of what they'd actually found underground. Not forever. Just long enough for everyone who saw it firsthand to die, for institutional memory to fade, for the truth to become legend, and for legend to become nothing at all. The chambers remain beneath Niagara Falls. The sealed sections stay closed. The deepest excavations still hold whatever was found there in the 1890s. You won't find answers in official records because the records were never meant to tell you what was really built down there. They were meant to tell you about electricity, about progress, about lighting up Buffalo. And that story is true enough, but it's not the whole story. The whole story is still underground, waiting in spaces built for purposes we've agreed to forget.